Yeah, hello and welcome back. So, we had been discussing about numbers and we saw how a number is represented in a general number system with a general radix R, and in this lecture we would be focusing on a few of the number systems which are the decimal, binary, octal and hexadecimal. So, these are the popular number systems. In decimal, the radix is 10, the digits are from 0 to 9. In binary, R is 2, digits are only 0 and 1, and these are called the bits, not digits anymore, these are called the bits. Octal, R is 8 and digits are from 0 to 7. In hexadecimal, R is 16. So, there are total 16 number of digits from 0 to 15. However, we know that after 9 normally we do not have a symbol for 10. We write 10 as 1 0 in decimal. So, we do not have a symbol for 10 as such. So, what we do, we write the alphabets starting from A in order to represent the quantities 10, 11, 12, 13, 14 and 15, and we use the symbols A, B, C, D, E, F. So, this A is basically the 10, B is 11, C is 12, 13, 14, 15 in the light of quantity. So, in the light of value. So, this is 13 value, not number. Okay. So, B is having 11 as its value. So, B is a number, its value is 11, D is a number, its value is 13. So, in hexadecimal these are the digits. So, this A, B, C, D, E, F are the digits. So, if placed alone, this is a number as well as a digit only, placed together it becomes a digit in a number. So, this 1 E2 is a hexadecimal number and each 1 E and 2 are the digits of hexadecimal. You can very easily calculate what this number, what the quantity or what the value of this number is. Simply 2 into 16 to the power 0 plus E is what? For calculation you will have to write E as 14, 16 into 1 plus 1 into 16 square. So, evaluate this, whatever will come is the value of this number 182. So, we represent for an example, we represent the quantity 12 in some popular number systems. So, in decimal it is 1 2. So, we now start referring to numbers as 1 2 like this, not by the value of 12 here. So, decimal is 1 2 and you notice that we have started writing this, started writing this suffix number here. So, what does this suffix mean? So, the suffix attached to a number, the number is these set of symbols, these set of symbols are the numbers. So, the suffix attached to this number gives the radix of the number system in which this number is represented. So, immediately we understand by noticing that the suffix is 10, we immediately understand that it is a decimal number system. So, 1 2 basically gives the quantity of 12 also, because it is a direct coding. However, in binary, to represent this quantity 12, the number becomes 1100. Why? Because if you expand 1100, you will find that whatever expansion has been taken out, if you evaluate this, you will find that it becomes 12. You will find that it becomes 12. Similarly, 1 4 in octal represents 12. It is very easy to see, 4 plus 8. Hexadecimal, C is 12 as we already know. So, this is how a particular quantity is represented in popular number systems. However, we need to have a particular algorithm in order to know what is the number which would represent that particular quantity. So, we have already studied if we are given a number, how can we extract that quantity, right. So, this is another example for 27, you can look at it later on. So, we have studied the way in which we can extract the quantity given the number and the number system, that is the radix. So, it is simply summation of d I r to the power of I. However, if we are given the quantity and asked to represent it in a certain number system, then how to go ahead, how to formulate that number which will give that same information, which will carry, which will contain the information of that value or the quantity in that particular number system, how to go ahead with that. So, in decimal system it is very simple, it is a direct coding. How to, the question is how to find the code for a general number system for any radix. So, look closely how the code is evaluated, this gives us the way in order to construct the number also. So, Q is basically this expression d0 r0 plus d1 r1 up to dn rn. So, if it is of length n plus 1. So, this is the expression. So, now if you divide it by r, so you are required to find. So, this is how the problem is posed, you are required to find this n plus 1 digits. So, you notice this. So, if you divide the quantity q by r, then what will be the remainder and what will be the quotient. So, if you divide this by r, then this part is having a r common. So, this part will get divided by r and this part will be left out, because this does not have an r, this part will be left out. So, the remainder will basically be d0. So, if you do a division by r on the number, then the remainder that you will get will basically give you d0, and the quotient that you will get will be this, because an r is extracted from here. So, it will be d1 r0 plus d2 r1 dn rn minus 1, because an r has been extracted from there. So, if you further divide this quotient q1 by r, then what will be the remainder that you will get? You will get the remainder as d1. So, the remainder will be d1 and the quotient then will be d2 r0. So, this part an r has been extracted from here, d2 r0 till dn rn minus 2. In this way, we can continue dividing until there is no more quotient or the quotient becomes 0, and the last remainder that you will get is dn. The last remainder that you will get is dn. So, this is the algorithm. So, this is the division algorithm with which we can find out the number from any value given. So, let us do some work in order to understand how to actually do this. So, one or two examples we will do. So, like this number we have considered 612. The problem is to represent this quantity in binary, octal or hexadecimal. The problem is also posed sometimes like this: convert 612 in decimal to binary, octal or hexadecimal. So, this is either posed as a problem of representing the quantity in certain number system or conversion of the number in decimal to certain number system. So, either way this problem can be posed. So, if you do it, you will get these answers. So, if you can do it on pen and paper and get this as answer, but I will just show you for the purpose of how to do it. So, how to go about it. So, this is like a tutorial also. So, you just notice what we are doing here. So, you have to do this, I guess this is called the ladder division method. So, you have to divide the number with the radix. So, radix of binary being 2. So, we are dividing by 2, and what is the quotient we are getting? 306. What is the remainder we are getting? 0. So, we write it like this. Okay. So, here the coefficient, here the remainder. So, the remainder I think we can write it here. We can write the remainder here 0, and immediately this becomes D0. Next division, next level division of this coefficient 1, 5, 3, no remainder, this is D1, 2, 7, 6, remainder is 1, D2, again you will get 38, 38, we should start referring to the numbers like their positions, 38, no remainder, this is D3, 2, 1, 9, no remainder, D4, 2, this is 9, 1 remainder, D5, 2, 4, 1 remainder, D6, 2, no remainder, D7, 0 remainder, D8, 2, 0, 1 remainder, D9, and we reach 0. So, we reach the quotient as 0 and then we stop. So, now the number is basically, you read the number as remainders from bottom to top. So, the number is 10011001000, you see 10011001000. So, this is the number. So, you get all the positions and then you simply write it down in write these digits, write these bits in their respective positions, that is all. Similarly, in octal, if you have the same number, you have to represent it in octal, you have to start dividing by 8. So, what would be the number here? 8 is 7, 6, 52, 8 is 6, remainder is 4. So, next you again divide by 8, you will get to 9, remainder is 4, again 8, 1, remainder is 1, 8, 0, remainder is 1. So, this is D0, this is D1, this is D2, this is D3. The number becomes 1144 in octal. So, this you have to write, this suffix you have to mention. Okay. So, the mentioning of the suffix is important, otherwise we do not know what in which number system your number is represented. So, this is very important. If you do not write it, you do not mention it, some marks will be deducted. So, this is to ensure strictness about your discipline of mentioning the suffix, mentioning the number system. Similarly, if you represent this in hex, so 612 in hex, so you have to divide by 16 So, when you divide by 16, so this is basically 4612. So, 46 4. So, I do not know why 4 is written here. I was looking at this. It seems it will be only 3. Okay, so 4 is the remainder. Sorry, I was confused a bit. Sorry for that. So, this will be 3. 316 is 48. So, 48 means 3 and 1, 132, and in 132 our 16 goes how many times? In 132, not 9, 8 times, I guess. 8 6 is 42, 8 6 is 42 and 12. So, is 4. So, the remainder is 4 here. 16 2 6, 16 0 2. So, once we reach 0, we stop the division and the number is basically read bottom to top. So, it is 264 in 6 in hexadecimal. So, you can see how we solved the problem very easily. So, the solution, the numericals are not very difficult, you have to only remember the steps. So, we have dealt only with whole numbers, but we can also deal with numbers having a radix point. So, in general it is called a radix point, not a decimal point. So, in general it is called a radix point. So, the digits in the left hand side of the radix point denotes the whole value. The total is the weighted sum of the digits, positions have positive index and radix is raised to positive powers. When we have digits in the right side of the radix point, then they denote the fractional value. The total is still the weighted sum of the digits. However, the positions are having negative index and hence the radix is raised to negative powers. So, that is why it becomes a fraction. So, the radix is raised to negative powers. Let us just look at this general number and how it is evaluated. So, the left part we have already have, or we know. You look at the right part. So, it is like this. So, d minus 1 is a suffix just here. So, d minus 1 perhaps it is 8, perhaps this may be 6, this may be 3. So, whatever it is multiplied with 1 by r in this case. It is multiplied with 1 by r square, it is multiplied with 1 by r cube. So, that is why this become fraction, that is why these become fraction. So, so this is about the fractional value, representation of the fractional values using a number system of radix r. How to find the digits to the right of the radix point? So, for that, so this is the same question asked for the fractional number. So, we are considering only the fractional number here. So, suppose we are given a whole number as well as a fractional number, like maybe we are asked to find out that 612 we had 612.625. Then you find out the whole number representation separately and the fractional number representation separately, and then you just club them together, that is all. So, we do not need to tackle this problem together, we can break it down into two problems representing the whole number separately, representing the fractional number separately, and this part we have already covered. This part is what we will see now. So, for that we again notice how the fractional number is represented. We notice that this value is basically the fractional value is represented. We notice that this value is basically d minus 1 r minus 1 plus dot 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 d minus n r minus n. So, if we multiply with r instead of dividing, if we multiply with r, then what will happen, this d minus 1 will come out, So, coming out means you will get this as a whole number and the rest part will be fractional, still fractional. So, when we multiply with r, you will get a whole number part and a fractional part. So, the whole number part that you get will be d minus 1, just the digit to the right of the radix point, the first digit to the right of the radix point you will get, and the remaining what will happen to the remaining. So, d minus 2 r minus 2 will now become d minus 2 r minus 1. So, the fraction that will be there, you have to multiply it with r again in order to extract the d minus 2. So, in this way we multiply by r one by one and take out the whole numbers one by one, and we will get the digits d minus 1 to d minus n. So, let us see an example of this particular 0.625. So, if we want to know what 0.625 in decimal will be in octal, binary and hexadecimal. So, for octal, also for binary, first we will do multiplication with the radix 2. What we get is 0, 5, 2, 1. So, what is the whole number coming out? 1. So, this will become d minus 1. You will carry forward in the next step only the fractional part and multiply with 2 only. What you will get? 0.5. So, what will be your so you can write, actually you can write at the side by making another column, that d minus 1 will be equals to 1, d minus 2 will be 0 now because the whole number was 0. So, next 0.5 into 2 will be 1.0 and d minus 3 will be equals to 1. So, as soon as there is no more fractional part, your algorithm will stop, your algorithm will terminate here when you will have no more fractional part. And what is the fractional part here? The fractional part is, so this is d minus 1 is 1, d minus 2 is 0, d minus 3 is 1. So, it is 1 0 1. So, this is the d minus 1. So, since both look same, d minus 1 and d minus 3, just pointing this out. So, if you are supposed to represent it in octal, then what you will do? You will multiply with 8 instead of 2, you will multiply with 8. So, let us do that. 0.625 into 0.625 into 8, this will give you 25. So, it is cancelling, the fractional part becomes 0 in one step. So, it might not so happen for a particular fraction. So, for 0.625 it happened like this. So, it is simply 0.5. So, you see it is simply 0.5 in octal. So, in hexadecimal, if you multiply with 16, you can very easily understand this is going to be 10.0, and since we have to represent this 10 by a single symbol here, that symbol is basically A. So, this is A16. So, I hope you understand, hope you got how you have to find out the number given a particular quantity, be it whole number, be it a whole quantity, be it a fractional quantity. You can always find out the number when you know the radix of that number system. So you can practice by taking some numbers in your own, by taking some quantities on your own, you can practice figuring out what would be the number. So when you figure out that number, also do a back calculation to check whether that number really represents that quantity. So you can always do that by doing a summation di ri, summation di r to the power I on that number, and again evaluate and find out the same number. So this you can do as a exercise for yourself. Also you will be supplied some tutorial sheet where you will be asked to solve such problems. So with this, this lecture ends, and thank you for your attention.